Hello everybody, it's good to see you all again. So as you can see, we're going to be looking at these circle proofs here. So note that circle proofs work just the same way as any other standard geometric proof here. The idea is, of course, just using what you already know and some of the theorems that we have here. You should already have a copy of this here. Take a look at the handout and you can see all this here. We're going to be using several of these theorems here. So we're going to take a look at this. So even though I mentioned that it's best to write these as paragraphs, I'm going to do this in two-column form for the time being. So we note in this situation, we can just mark down the information we have. We know P is the midpoint of AQ here, so I'm going to mark these two pieces here. We want to show AB is congruent to QB. So it's pretty obvious here to note that we have triangles APB and QPB here, and that gives us a line of attack. We know that PB should be congruent to itself, so that looks pretty good here. Now, they told us that AB is the diameter of circle O, which guarantees us that this arc AB down here is half a circle. So therefore, APB here has to be a right angle here, right? Because it's intercepting an arc of measure 180. And since that's 90, we know that's 90 as well. So that's going to be important. So it looks like what we got here is two triangles done by SAS. So we're going to go ahead and do that here. So I'm going to go ahead and write this one out and do this one at a time by this here. And we're going to see how this thing should work here. Okay. So note that we're going to use side angle side to prove the triangle is congruent here. So I think the first thing we need to do is ensure that we have our pieces. So I'm going to start with the fact that P is the midpoint. So I'll mention that here. P is the midpoint of AQ here, and that's given to us. Okay? And now we know that because of that, we can use the midpoint definition. So that gives us QP is congruent to AP here, right? And that's a pair of sides. This is our definition of midpoint here from step 1. Okay, now we need to deal with the angle bit here. So note that in this situation, we need to get the angles here. We're going to start with the fact that these two are here. AB is a diameter and P is a point of the circle. We'll take a look here at that. So I'm going to list these both together. Those are also givens as well. Okay, now we can invoke Thales' theorem, right? An angle inscribed so it intercepts a semicircle is a right angle, so we can mention that here. So I can say angle APB is a right angle here. So we can mention that an angle, an inscribed angle that intercepts a semicircle is a right angle. And that is from step 3. Now we note that this is a straight line here, so that means these are supplementary angles here, so that also has to be a right angle. So we can mention that QPB is a right angle. And we can mention an angle supplementary to a right angle is also right. Okay? So that's from step 4 here. And now we can continue with this here. We note that in this case that makes the two angles congruent, so I can say APB is congruent to QPB. And that's my pair of angles here. We know that all right angles are congruent, so I can mention that. And that's from step 5 and 4. Oh, I apologize. Yes, 5 and 4. And then now we also have PB is congruent to itself. And that's another thing here, so we know that that's our reflexive property. And then we can see that the end is near. We can mention that here. So now we can use the congruent triangle. So we can say that QPB is congruent to APB by side angle side. And that's from steps 2, 6, and 7 as I've marked here. 2, 6, and 7. And finally in step 9 here, we have AB is congruent to QB here. And then we can say that corresponding parts of congruent triangles are congruent. Step 8. Now, of course, you could also choose to do this in paragraph form, and that's perfectly fine, but perhaps it may be better to do this on the Regents to write it out in 2-column form here. Okay? Hope to see you again soon.